Hi, my name is Andrew McLaren. Today we're going to go over my estimation trick for scientific notation, but in the context of dimensional analysis. So you can see right here that we have a 1.5 and we're dividing that by 39.3, and we also have this 10 up to the sixth power, and then we've got 1,000, which is the same as 10 up to the third power in the denominator. So using some of our math tricks here, we can get a pretty good estimate of what our number should be. If we're just looking at the back numbers, you've got 10 up to the sixth divided by 10 up to the third. So that should be 10 up to the third power just from those back numbers. But we also have like 1.5 divided by 39.3. If this was 15 and 30, this would be like 0.5. So it's not like 0.5, it's like 0.05-ish from that. And if we want to bring the place value over 2 places, we're going to make this 2 times bigger. Then we should make this 2 place values smaller. So if we look at the actual calculation on this problem, you can see we've got 1.5 times 10 up to that 6th power. Divide that by 39.3. Sorry, 39.3. And then we can divide that also by 1,000. And we get, yeah, pretty close to what we're trying to do. We've got like not 5, but it's like 4-ish. So it's a little bit smaller than 5. But it is times 10 up to the first power. So we're pretty close, and this gives us fairly good confidence about the front number and the back number. If you wanted to just do like the 1.5 divided by 39.3, that's going to give you the correct numbers. They're just in the wrong place value. If you just do all these things that aren't like 10 up to some powers, you'll combine the numbers correctly, but then you need to like move that place value to get it to be the correct number. And then we can also, in a similar regard, we can say if we've got like 672 nanometers, you can combine these conversions using those exponent rules for the back number, like what we're talking about here and there in the previous video on this that I've made, to combine the nanometers to meters and the meters to like picometers conversions. So if you have 1 meter, that's going to be 10 up to the 9 nanometers. And in 1 meter, that's going to be 10 up to the 12 picometers. You could work with this being like 10 up to the -9 and this being 1. But for me, it's easier to see this with the 1 meter equivalency. It just works a little bit cleaner. And what we can see is that these are kind of like your back numbers. You're combining the 12 and the 3, and they're canceling out in a way where it's like 12 minus 9. So if we're just looking at those back numbers, it's kind of like 10 up to the third times this 673. But if we want to make this number a bit smaller, we're going to need to make that a bit bigger. So we can do this calculation. We got 672 divided by 10 up to that 9th power times 10 up to the 12th power. In other words, yeah, I don't know why I said 3 there. In other words, we're right on the money with our estimation. So using this front number, back number trick can help you use dimensional analysis to get pretty quick numbers in these types of calculations.